The waters of the South China Sea are transforming into what many defense analysts now call the most volatile maritime zone on our planet. Beijing's naval expansion continues at an alarming pace, constructing militarized artificial islands, deploying advanced carrier strike groups into contested territories, and signaling an unmistakable shift in regional power dynamics. Yet beneath this surface tension, Washington has been orchestrating something extraordinary. The United States Navy hasn't merely been observing this transformation. They've been engineering a response that could redefine naval supremacy for generations to come. What you're about to discover isn't a collection of conventional armaments or standard warships. These are 5 revolutionary weapons platforms and integrated systems, each meticulously designed for an entirely new dimension of maritime conflict. Imagine warfare where hypersonic projectiles traverse hundreds of miles in mere minutes, where autonomous drone formations blanket the skies in coordinated swarms, and where sophisticated electronic countermeasures can disable targeting networks across vast oceanic expanses. Every single system addresses a critical weakness in America's Pacific defense architecture, vulnerabilities that Beijing had been quietly planning to exploit. While China has concentrated on expanding fleet numbers and submarine counts, the Pentagon has been pursuing a fundamentally different strategy. They've developed 5 technological ecosystems that completely rewrite the fundamental principles of naval engagement, rendering traditional military metrics nearly obsolete. This is the arsenal keeping Chinese strategic planners awake through sleepless nights. Let's explore what makes these weapons so profoundly transformative. Stretching nearly 15 feet in length and tipping the scales at 1,900 pounds, this isn't simply another air-to-air munition in America's inventory. The AM-174B Gunslinger represents a flying computational weapon system with engagement ranges exceeding 300 miles, capable of neutralizing virtually any airborne threat it encounters. Consider that range advantage. It's triple the reach of the legendary AM-54 Phoenix that once equipped F-14 Tomcats during the Cold War. This extended envelope means FA-18 Super Hornets can now eliminate Chinese aircraft long before those adversaries even detect American presence in their airspace. Beyond its impressive range, the Gunslinger serves as the primary defensive shield against supersonic anti-ship missiles threatening U.S. naval installations across the Pacific theater. This weapon's development showcases one of the Navy's most ingenious adaptations in recent decades, building upon the proven SM-6 interceptor platform. Since 2013, the SM-6 surface-to-air missile had been defending carrier strike groups, but a visionary team at Naval Air Systems Command posed a revolutionary question. Could this ship-launched interceptor be adapted for fighter aircraft deployment? The engineering obstacles were formidable. The SM-6 had been specifically engineered for destroyer and carrier launch systems, which permitted considerably more flexibility regarding dimensions, mass, and deployment mechanisms that large warships could accommodate. This weight exceeded anything the Super Hornet had previously carried on individual hardpoints. The Phoenix was 900 pounds lighter and 2 feet shorter. Additionally, the aerodynamic properties of a 13.5-inch diameter missile operating at high altitude rather than being boosted from sea level demanded entirely new calculations and testing protocols. Engineers partially addressed the weight challenge through a sophisticated multi-mode seeker derived from the AMRAAM platform, enlarged and enhanced with advanced data link capabilities. This networking allows the missile to receive continuous targeting updates from any sensor node in the integrated battle network. Ship-based radars, AWACS aircraft, or orbital surveillance satellites. A Super Hornet can launch from beyond Chinese radar detection range, immediately turn away, and allow the missile to prosecute its target using data transmitted from an E-2D Hawkeye orbiting 200 miles distant. Chinese forces never observe the launching aircraft, never achieve radar lock, never get warning until an incoming missile suddenly illuminates their threat receivers, leaving mere seconds for defensive response. The integration with existing Navy infrastructure makes this capability particularly devastating. Every Aegis destroyer and cruiser throughout the fleet already operates SM-6 missiles and possesses the fire control architecture to guide them. Now, those identical warships can provide targeting information to air-launched variants, creating an integrated air-sea defense bubble extending hundreds of miles in every direction. The Navy didn't require new radar systems, new communications infrastructure, or new training curricula. They simply adapted existing capabilities to a revolutionary new application. The genuine paradigm shift arrived in June 2025 when the Missile Defense Agency published a procurement solicitation for new wide-area effect warheads specifically engineered for the AM-174B. The request specified warheads employing novel defeat mechanisms against hypersonic threats, adjusting exotic technologies including directed fragmentation patterns or possibly electromagnetic pulse effects. These aren't merely larger explosives, they're specialized hypersonic killers designed to compensate for the extreme velocities and unpredictable flight paths of China's most feared weapons. The program is advancing at unprecedented velocity. Initial operational capability was achieved in July 2024, merely months after the first photographs emerged showing Super Hornets carrying these weapons. By September, they were deployed operationally with carrier air wings throughout the Pacific. The Navy plans to procure 200 missiles during 2026, with production accelerating at Raytheon's Arizona manufacturing facility that already produces SM-6s for the surface fleet. China cannot easily counter this weapon system. Their naval formations depend on layered air defenses with engagement ranges typically maxing out around 100 to 150 miles. Their longest-range air-to-air missile, the PL-15, can potentially reach 124 miles under optimal conditions. The AIM-174B outranges all of them, and critically, it doesn't require the launching aircraft's radar to guide it throughout the entire engagement. Moreover, this missile is fundamentally designed as a deterrent rather than a strike weapon, which provides greater security for the U.S. Navy to operate closer to Chinese territorial waters and employ its already extensive arsenal and fleet to maximum effect. Speaking of the fleet, the Navy's Virginia-class submarines are receiving a desperately needed weapons upgrade, enabling them to strike faster, harder, and with virtually no response time for adversaries. We're discussing the CRAW, Compact Rapid Attack Weapon. This upgrade is specifically designed to enable submarines to fire more frequently and more rapidly than ever before conceived. To understand the significance of this next-generation system, we need to examine its predecessor. The Mark 48 torpedo itself contains nearly 5 decades of evolutionary development that began with a straightforward proposition. What capabilities are necessary to reliably destroy a submarine? During the Cold War, the answer centered on speed, stealth, and fire-and-forget functionality. The Mark 48 emerged as one of the most intelligent submarine-launched weapons ever created, featuring a warhead containing less than 700 pounds of explosives within a 3,000-pound casing. The onboard sonar and internal processing systems enable it to track intended targets autonomously, even executing course corrections if it misses on the first pass. However, that capability proved insufficient for modern warfare requirements. Layered defensive systems, advanced maneuvering techniques, and sophisticated jamming technologies meant torpedoes were becoming progressively less accurate against contemporary threats. The solution involves implementing the identical proven strategy currently enabling Ukraine to hold off Russian advances: smaller, more numerous weapons. The Mark 58 CRAW represents the next generation, in development for over 2 decades as the common very lightweight torpedo, initially conceived as an anti-torpedo defensive system. The original concept proposed that carriers and high-value ships could launch small interceptor torpedoes to destroy incoming threats. But Navy planners quickly realized that if a 220-pound torpedo could intercept and destroy another torpedo, it could certainly handle submarines and surface vessels. The engineering breakthrough emerged from completely abandoning traditional torpedo design philosophy. Heavy torpedoes like the Mark 48 are essentially underwater missiles, engineered for extended range and massive warheads. The CRAW takes the opposite approach entirely. It functions more like an underwater fighter jet, trading extreme range and payload capacity for superior maneuverability and quantity. Its 6.75-inch diameter is less than half that of a Mark 48, yet modern electronics and explosively formed penetrator warheads enable it to hunt down submarines with devastating effectiveness. But the Mark 58 itself represents only part of the equation. If you employed the same launching tubes used with the legacy design, you'd waste enormous amounts of space. This is where the revolver-MP program enters the picture, which began testing in 2023. Theoretically, the revolver-MP redesign permits up to 10 CRAWs to fit in each torpedo tube using a rotating drum mechanism similar to a revolver cylinder. That means a Virginia-class submarine's 4 torpedo tubes could ripple-fire 37 torpedoes in under 60 seconds. China's submarine force, constructed around Soviet-inspired designs emphasizing single, powerful weapons, has no answer for this capability. Their Type 039 and Type 093 submarines carry between 14 and 20 torpedoes total. A single Virginia could launch twice that quantity from its torpedo tubes alone while maintaining heavyweight Mark 48s in reserve for capital ships. But the Navy isn't stopping with this innovation. The Block 5 Virginias, equipped with their Virginia payload module, add 4 large tubes, each originally designed for 7 Tomahawk cruise missiles. These tubes could theoretically be retrofitted with CRAW launchers holding up to 20 mini-torpedoes each. That's 80 additional weapons without sacrificing any traditional torpedo capacity. Combined with the original proposal for a modified torpedo room loadout, which suggests 160 CRAWs plus 10 Mark 48s in the same space normally holding 26 heavyweights, a single submarine could carry 250 torpedoes. The logistical advantages are staggering. CRAWs utilize identical fire control systems as existing torpedoes, requiring only modified software. They're maintained using the same equipment, stored in the same magazines, and loaded through identical hatches. The Navy doesn't need new submarine tenders, new training facilities, or new weapons depots. Everything integrates seamlessly with infrastructure built over 50 years of submarine operations. Consequently, each submarine is now capable of engaging multiple targets with practically identical accuracy and substantially higher chances of penetrating defensive systems and interceptions. While submarines are leveraging increased weapons capacity to enhance their first strike capabilities from the shadows, another system aims to simulate entire fleets, overwhelming opposing detection systems and potentially forcing rapid capitulation. Enter Nemesis, netted emulation of multi-element signature against integrated sensors. This system emerged from over 15 years of classified research that's only recently becoming public knowledge. The program's origins likely trace back to fundamental studies on how modern naval radars process information. Researchers discovered that advanced radar systems don't simply detect metal objects. They analyze dozens of characteristics including motion patterns, electromagnetic emissions, and even wake turbulence signatures. This meant traditional decoys that merely reflected radar waves became increasingly ineffective against modern threats. Nemesis pursued a radically different approach. Instead of concealing ships or confusing radars, it creates completely false naval forces that are virtually indistinguishable from genuine vessels. The first documented appearance of the Nemesis system in U.S. government documents occurred in 2013, when the Navy described it as a system of systems to coordinate distributed electronic warfare resources against many adversary surveillance and targeting sensors. In practical terms, Nemesis was initially proposed as a system that would operate against any radar or detector oriented toward incoming U.S. Navy forces. The actual specifications and capabilities of the system would remain tightly classified for several years. Only in 2024 did we observe the first proposals for implementing a system that operates under the Nemesis umbrella through the LEAD long-endurance electronic decoy. The LEAD system reportedly consists of small, unmanned aircraft that fly predetermined patterns while broadcasting sophisticated electronic signatures, but calling them decoys dramatically undersells their capability. Each LEAD drone carries multiple RF transmitters that can simulate everything from the radar return of a destroyer's superstructure to the electromagnetic noise generated by its engines and electronics. They operate at wave-top height at 30 to 35 knots, typical destroyer speeds, and can maintain their headings for over 10 hours. The revolutionary element is the networking capability. Using mesh network technology, multiple LEAD drones coordinate their movements to maintain proper fleet spacing and formation. They can accelerate and turn together, maintaining the illusion even under close observation. 12 drones can simulate an entire destroyer squadron, complete with picket ships, plane guards, and formation changes that appear completely authentic to enemy sensors. China's entire anti-access area denial strategy depends fundamentally on long-range targeting capabilities. The DF-21D carrier killer missile relies on satellite reconnaissance and over-the-horizon radar to locate American carriers. But if sensors detect multiple carrier groups, which one do you engage? If China only possesses enough missiles for one salvo, they likely won't rush to strike at phantom targets, giving the U.S. more operational flexibility to approach for their own standoff operations. The integration with existing fleet operations is seamless. LEAD drones launch from the same rails used for target drones on destroyers and cruisers. They're controlled through identical combat systems that manage other unmanned assets. Most importantly, they can intermix with real ships, so 3 destroyers and 9 LEAD drones could create the impression of a 12-ship surface action group. Budget documents from fiscal year 2025 reveal the Navy purchasing 120 lead systems at roughly $3 million each. Pocket change compared to the billion-dollar ships they protect. But the program is expanding beyond simple ship imitation. Next-generation lead variants under development could simulate aircraft formations, submarine signatures, and even the acoustic and thermal signatures of nuclear reactors. The Navy is betting that in future conflicts, the first battle won't be between ships and missiles, but between reality and deception. Speaking of drone improvements, Navy destroyers are receiving a significant upgrade in drone warfare capabilities with the Roadrunner M from Anduril. One fundamental premise drove this development. What if interceptors weren't actually single-use weapons? The development timeline was shockingly rapid by defense industry standards. Anduril leveraged commercial drone technology, off-the-shelf jet engines from the model aircraft industry, and software architecture from Silicon Valley rather than traditional defense contractors. The prototype flew in 2021. By 2024, Special Operations Command was conducting combat trials. In March 2025, the Navy declared that the Roadrunner system would be one of the options for integration onto Arleigh Burke destroyers that follow Gerald R. Ford-class carriers on patrol missions worldwide. The drone's development cycle was miles ahead of traditional U.S. procurement timelines. The genius lies in the simplicity. The Roadrunner M employs two turbojet engines specifically designed to enable the vertical launch and recovery system. According to Anduril, the engine's thrust-to-weight ratio is virtually unparalleled. The critical capability here is the weapon's ability to intercept a missile or drone swarm using a contact detonation warhead that creates a wider area of effect. Theoretically, the system should neutralize multiple drones or missiles moving in close proximity. But the revolutionary feature is the drone's ability to return if not deployed. Simply stated, if detection systems fail to properly lock onto a viable target or targets disappear before the Roadrunner can maneuver into engagement range, the autonomous navigation system guides the drone back to its launching platform where it can land and be refueled for its next mission. Notably, the interceptor still destroys itself on a successful engagement, much like traditional anti-air designs such as Patriot-compatible missiles. However, the key advantage is economic. Anduril has indicated that each Roadrunner costs only low six figures, supposedly much lower than comparable contemporary anti-aircraft and missile interceptors that the U.S. Armed Forces previously accessed. Each SM-2 missile costs $2 million. A rolling airframe missile costs $900,000. Even the economical ESSM runs $1.5 million per shot. If the Roadrunner lowers production cost to $200,000 and adds redundancy by being recoverable if it misses, it can be procured in much larger quantities to enable a more comprehensive defensive system. The numbers are what ultimately matter. A Burke-class destroyer carries 96 vertical launch cells. Suppose half are loaded with defensive missiles. A single missile or drone swarm targeting the carrier group might require launching multiple interceptors to destroy them. This reduces the number of possible interceptions to a few dozen at best. But with the Roadrunner M, as soon as the threat is eliminated, the additional drones can simply be refueled and slotted back into the ship's launcher. This practically ensures that the system can defend against as many targets as it has interceptors available. Last but certainly not least is the proposal to revive a project once deemed a catastrophic failure, the USS Zumwalt. These multi-billion-dollar destroyers were initially slated for decommissioning as their costs severely exceeded budget projections. But the Navy made a radical decision in 2021. They would remove the advanced gun systems and install the capability to launch a new class of hypersonic missiles, the conventional prompt strike weapons. The weapons history reaches back to 2003, when DARPA initiated the Falcon program, exploring whether America could strike anywhere on Earth in under 1 hour without employing nuclear weapons. The Army continued the research in 2011 with the Advanced Hypersonic Weapon Program, conducting the first successful flight from Hawaii to Kwajalein Atoll. The results were impressive. The missile covered 2,300 miles in less than 30 minutes. The Navy joined the program in 2018, but with a crucial difference. While the Army focused on truck-mounted launchers for island bases, the Navy wanted to launch from ships and submarines. This required solving unprecedented engineering challenges. Hypersonic weapons generate temperatures exceeding 3,000 degrees Fahrenheit. Launching them from a ship's vertical cells, surrounded by other weapons and fuel, seemed impossibly dangerous. The solution came from an unlikely source, NASA's Space Shuttle program. Lockheed Martin's Engineers adapted heat-resistant materials originally developed for the shuttle's cargo bay to line the Zumwalt's new weapon cells. The Zumwalt's launch tubes, originally designed for the canceled Advanced Gun Systems ammunition, would be retrofitted to receive and launch CPS missiles. The CPS is virtually uninterceptable with current technology because it's not a ballistic missile following a predictable arc through space. After the boost phase, the hypersonic glide vehicle separates at around 100,000 feet and begins its unpowered glide at speeds exceeding Mach 5. But unlike a ballistic warhead following gravity, the wedge-shaped glider can perform banking turns, pull-up maneuvers, and even reverse course. Instead of high-yield explosives, CPS uses tungsten kinetic penetrators, essentially a hypersonic hammer that destroys targets through pure kinetic energy. At Mach 5, a tungsten rod carries the same energy per kilogram as TNT, but concentrated into a minuscule impact area. It can pierce underground bunkers and hardened aircraft shelters, as well as carrier flight decks. Then, the explosive payload aboard the missile can complete the destruction. The June 2024 test from Hawaii to the Marshall Islands demonstrated the weapon's effectiveness at extreme ranges, reportedly striking within 6 feet of its intended target after traveling over 2,000 miles. That's accurate enough to hit a specific building in Beijing, launched from a submarine near Guam. The Navy isn't simply banking on the few Zumwalts in service. While each Zumwalt will carry 12 CPS missiles, Virginia Block 5 submarines are expected to carry 4 in the near future. But the real force multiplier comes from the joint program with the Army, as the system is also being developed for truck-mounted launchers. This shares development costs, combines production runs, and allows for better supply of components and replacement parts, which ultimately means both services acquire more weapons for less investment. When combined, these 5 weapons create an interlocking web of defensive and offensive capabilities that propel the U.S. Navy's operational capacity beyond what was previously imaginable. Picture this scenario. A carrier strike group approaches the South China Sea. Lead drones spread out ahead, creating false signatures of additional ships. Chinese satellites and radars detect what appears to be 3 carrier groups instead of 1. Super Hornets launch from the real carrier, each carrying AIM-174Bs that can engage Chinese fighters before they even take off from mainland bases or destroy incoming missiles that the Chinese military has decided to employ. The fighters don't need to approach close, as they're receiving targeting data from an E-2D Hawkeye that's itself protected by Roadrunner Ms cycling through defensive patrols. Below the surface, Virginia submarines slip through Chinese submarine patrol areas, each carrying enough CRAW torpedoes to engage entire ship and submarine squadrons while saving their Mark 48s for when aircraft carriers arrive with support. If Chinese commanders order their surface fleet to engage, they face a terrible choice: spread out to avoid submarine attack and become vulnerable to CPS strikes from Zumwalts, or concentrate for mutual defense and risk losing multiple ships to a single hypersonic impact. The integration with existing Pacific infrastructure makes this especially potent. The U.S. already maintains multiple bases surrounding the South China Sea, including several in allied countries like South Korea, Japan, and Singapore. The Marine Corps is being completely restructured to provide littoral combat and area denial capabilities. The U.S. Air Force is gradually deploying the B-21 stealth bomber and next-generation fighter jets, which promise even better range and weapon capabilities. China's counter strategies all encounter fundamental problems. They can't match the AIM-174B's range without completely redesigning their aircraft and missiles. They can't overwhelm Roadrunner defenses without building more drones than their industry can produce. They can't locate the real ships among lead decoys without getting close enough to become vulnerable. They can't stop CPS missiles with current technology. And they can't match the CRAW's numbers without redesigning their entire submarine force. These weapons are arriving at a critical moment. Most analysts suggest that 2027 represents the year with the highest risk for a broader Taiwan conflict that could draw the U.S. into war with China. By that time, all 5 systems should be at least partially operational and tested for efficiency. The Pacific Fleet will possess hundreds of AIM-174Bs, thousands of CRAWs, dozens of CPS missiles, and enough lead and Roadrunner systems to protect every high-value unit. China's window of opportunity, if it ever existed, is rapidly closing. If you found this analysis valuable, make sure to subscribe to IntelX for daily deep dives into the weapons systems and technological innovations reshaping global military power. Hit that notification bell so you never miss our coverage of the developments that are redefining modern warfare. Check out our previous video on next-generation Air Force capabilities, and stay with us as we continue exploring the cutting edge of defense technology and geopolitical strategy